Alright, neuro nerds, it's time to talk about Guillain-Barré syndrome. So as I said in a previous video, Guillain-Barré syndrome is an autoimmune disease of the peripheral nervous system, so that means it's going to affect the lower motor neurons, whether they be motor, sensory, or autonomic. So that means we're going to see progressive weakness in the limbs and then potentially absent or just diminished deep tendon reflexes. The most common type of Guillain-Barré syndrome is acute inflammatory demyelinating polyneuropathy, or for short, AIDP. So the etiology of Guillain-Barré system is rapidly evolving ascending weakness, mild sensory loss, and hypo or areflexia, progressing to a nadir over up to 4 weeks. So nadir is just a medical term that means at the lowest point. So another place you might hear this term nadir is in cancer treatment. After a person has gotten chemotherapy, their nadir is when they're at the lowest point of or have the lowest amount of white blood cells active. And so in Guillain-Barré syndrome, nadir means the lowest point of progression of that weakness and sensory loss and autonomic dysfunction. So in Guillain-Barré syndrome, the immune system attacks myelin, not myelin, surrounding the peripheral nerves, and it is preceded most typically by viruses like Epstein-Barr virus, cytomegalovirus, AIDS, and then the other one I didn't include here because I'm a stupid is one called Campylobacter jejuni, or C. jejuni for short. It can also be associated with recent surgeries. The pathophysiology of Guillain-Barré syndrome is an inflammatory process is enacted that affects Schwann cells, causing primary demyelination of the axons of the peripheral nervous system. So Schwann cells essentially are the cells in our peripheral nervous system that produce myelin or can remyelinate damaged myelin. In the central nervous system, it's cells called oligodendrocytes. But in Guillain-Barré syndrome, you typically have the axon remaining intact. Now, when the axon is intact and people are recovering from Guillain-Barré, remyelination can occur fairly quickly. But if the axon is damaged, which can happen, then Wallerian degeneration must occur. So that's basically like if this is the point of injury along the axon, then what'll happen is it'll actually die off a little bit higher up, and then that portion will die, and then you'll get a branch coming off the still live portion, and then that will regrow out. So that's what Wallerian degeneration is. And this occurs at a rate of approximately 1 millimeter per day. So this is by far the most complicated slide in this presentation, and I will have 2 more parts to Guillain-Barré syndrome after this, just to try to keep the videos shorter. But I wanted to talk through what's going on the neuronal level. And so that is a neuron. Up towards the left, you have the dendrites, and then the neuronal body, and then everything going to the right is the axon, and then the little pill-looking things around them, that's the myelin. And so on the first myelin sheath in the top picture, you have the little red triangles. Those are the antigens of the viruses that we discussed before. And then there's like little purple upside-down Ys. Those are the auto antibodies. And so they will attach themselves to the antigens. The antigens will attach themselves to the myelin, the antibodies attach themselves to the antigens, and they start breaking down the antigens. As that process occurs, what we call a membrane attack complex it begins, and that's on the second myelin sheath there. That you can see that causes, in the third pill, if you will, causes inflammation and then breakdown. Hey, sweet pea. Breakdown of the myelin, and then in the last bit you see that little circular thing. That is a macrophage, which is going to start eating all the debris. Well, what happens is it starts to eat the myelin sheath, which then can lead to damage of the axon. So the bottom picture is the exact same process, except you'll notice it's in between the 2 myelin sheaths. That's where the antigen attached itself. So that's in an area known as the node of Ranvier, or a node of Ranvier, and that is just uncovered axon. And so the antigen attached itself to the uncovered axon Then the antibodies attach itself to the antigen, and as you go further down, you see that that causes inflammation and then damage of the axon itself, and then that macrophage right up there starts to actually eat the axon, because that's where the damage occurred. And as these free-floating debris start to come off as a result of the membrane attack complex, the macrophage will just start eating up all of it, and it is attacking the peripheral nerve itself.